inshallah, is to evaluate the binomial coefficient, expand the binomial raised to a power, and find a particular term in a binomial expansion. Before we go through the binomial theorem, let's understand what the meaning of binomial. The meaning of binomial is the sum of two terms, or the difference between two terms is called binomial. Don't forget that trinomial is a three terms expression. Any expression in the form a plus b to the power of n is called power of a binomial. So a plus b is a binomial, but a plus b all to the power of n is called power of a binomial. Quickly, let's revise how we were expanding bracket to the power of 1 and bracket to the power of 2 and bracket to the power of 3. If you remember, if I have a bracket a plus b to the power of 1, it gives me two terms. The first one is a and the second one is b, and both of them to the power of 1. But if you have bracket to the power of 2, it gives me three terms, a squared and twice the product of a and b squared. So the number of terms is increasing the power by 1. Number of the terms is increasing the power by 1. So if I have a binomial expansion or binomial brackets to the power of 3, it gives me 4 terms. Here, the 4 terms for a plus b to the power of 3. It's the first to the power of 3 plus 3, the first square multiply the second, plus 3ab squared plus b power 3. For the bracket to the power of 2 and the bracket to the power of 3, you should be aware of how to expand them quickly without writing any kind of steps. To practice on this part, here is a rule for a plus b, a binomial to the power of 3, and here is the rule is given, and I wanted to expand this bracket. So let's start with a. 2x plus 3 to the power of 3. So I have 2x plus 3 to the power of 3. So in this case, the value of a is 2x and the value of b is equal to 3. So let's plug in or replace the value or substitute into the equation. So a, which is 2x to the power of 3, and the last term is b to the power of 3. Then I have 3 and 2x all to the power of 2 multiplied by b, which is equal to 3, plus 3 and 2x multiplied by 3 power 2. Now let's expand and simplify this expression. 2 to the power of 3 is 8x to the power of 3. This value is 3, and 2 to the power of 2 is 4, and here is 3. So 3 by 4 by 3, which is equal to 36. So it's 36x to the power of 2. Plus 3 and 2, and 3 power 2 is 9. So 3 by 2 by 9, and 3 times 2 is 6, times 9 is 54. So it's 54x to the power of 1. Plus 3 to the power of 3 is equal to 27. So when I expand 2x plus 3 to the power of 3, it gives me 4 terms. Notice that the power of x is arranged in descending order since I start with x. So x power 3, x power 2, and then x to the power of 1. For the second equation, b, x minus 5 to the power of 3. So I know that it's the first term to the power of 3 plus the last term, which is negative 5 to the power of 3. Then 3, the first term squared multiplied by the second term, plus 3, the first term to the power of 1, but the second term squared. So let's simplify it. It gives me x power 3, and negative 5 multiplied by 3 is negative 15, x to the power of 2. And then negative 5 squared is 25. Multiplied by 3 is 75, x to the power of 1, and negative 5 to the power of 3 is negative 125. So it's very important to understand how we can expand a binomial to the power of 3 without writing the bracket 3 times. Let's start first by how to find the binomial coefficient. Let's start first by how we can find the binomial coefficient. And the binomial coefficient, before turning to the power of the binomial, we should have a special notation that uses the factorials to find the coefficient at the front of each term of a binomial theorem. As we can see, n above r, we read it as n above r is equal n factorial divided r factorial multiply n minus r factorial. Give you time if you want to write it down. Then, for example, 6 above 3, how we can evaluate each of the following. 6 above 3. Without using calculator first, then I'm going to show you how to do it with using calculator. Without using calculator, 6 above 3 is 6 factorial divided by 3 factorial and 6 minus 3 factorial. So 6 minus 3 here, it gives me 3. And what is the meaning of 6 factorial? 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. So 6 factorials, I can expand it by that. And then 3 factorial, 3 times 2 times 1 times 3 factorial, 3 times 2 times 1. By cancel 3 to 1 with 3 to 1, and by cancel 6 with 2 times 3, so 5 by 4 is equal to 20, So 6 above 3 is equal to 20. Later, while you are studying permutation and combination, you will find that 6 above 3, it's like combine 3 terms out of 6 choices or 6 given target or elements. 6 above 0 for number B, it's 6 factorial divided by 0 factorial multiplied by 6 minus 0 factorial. Notice that 0 factorial is equal to 1. And also 1 factorial is equal to 1. So it's 6 divided by 6, which is equal to 1. And from here, we can rewrite a rule or a hint that n is above 0 is equal to 1. N above 0 is equal to 1. And another hint that n above n is equal to 1. Another example, evaluate 8 above 2. 8 above 2. So it's 8 factorial divided by 2 factorial multiplied the difference between 8 and 2, which is equal to 6. So it's 8 factorial divided by 2 by 6. How I can simplify it? I know that 8 is equal 8 by 6 by 7 by 4 by 5 by 3 by 2 by 1, and 2 is 2 by 1 and 6 factorial. So I can rewrite it as 8 multiply 7 multiply 6 divided 2 by 1 by 6. By cancel the 6, and 8 by 7 is 56 divided by 2 is equal to 28 without using calculator. With using calculator, how I'm going to solve it? I will just press first 8 and then C 2. How I can find C in my calculator? By press shift divided. You know the bottom of division, you will find above it something called NCR. So you press it. So 8 shift divided 2, it will give you 28 directly. And 3 factorial, or 3 above 3, it's a 3 factorial divided by 3 and the difference between them. And 0 factorial, don't forget it's equal to 1, not equal to 0. So it's a 3 multiplied by 1, which is equal to 1. Now let's expand the formula of how we can find the binomial theorem for a binomial power. Each expanded form of the binomial expression is a polynomial. Observe the following pattern. Number 1, the first term in the expansion of A and B. So we can notice that the first term here is taking the first term to the power. Then, by decreasing each one in the next term, and then the exponent on n is in the expansion a plus b increasing by 1 in the next term. So we can notice here is n, and then n is start decreasing, and then b start increasing. If here is 1, so 2, so 3, and so on until we reach the power. To understand more how we can use the binomial theorem to expand, let's start with the first example. First example, by using the binomial theorem, is to expand x plus 2 to the power of 4. And as we are aware that x plus 2 to the power of 4 will give me 5 terms. It will give me 5 terms. The first term is going to be x to the power of 4 as a to the power of n. And the last term is going to be 2 to the power of 4. So let's write it down. Let's write it down as 4 and 0 for the first term. Notice that below the first term we subtract 1. Then 4 and 1. Then 4 and 2, 4 and 3, and 4 and 4 to the power of 4. Notice that x here was power 4, then x power 3, then x power 2, then x power 1. Then the last term there is no x. So actually we can say that each term consists of 3 components. Each term consists of 3 components. The first component is the power, which is equal to 4, and the second value here is less than the number of the term by 1. For example, I'm looking for the second term, so the value here will be 1. Then the first term, and the first term is here is x, and 4 minus 1 is 3. Then the second term, which is 2, and 2 taking the base. Now let's simplify it. I can use my calculator to simplify, and if I'm not allowed to use my calculator, I can use the method of the binomial coefficient we just solved it a few minutes ago. Then we know that 4c0 is equal to 1, so the answer here is 1x above 4. And 4c1, or 4 above 1, is 4, multiplied by 2 is 8. So 4 multiplied by 2, I'm going to write it as 8. And then 4 above 2 is equal to 6, and 2 to the power of 2 is equal to 4. By multiplying them, the answer is 24. And then 4 above 3 is 4, and 2 power 3 is 8. So 8 multiplied by 4 is 32. And notice that the power of x is decreasing from 4 to 3 to 2 to 1 to the term without x. So x plus 2 to the power of 4, when I expand it, it gives me 5 terms by using the binomial theorem. Now, how we can expand bracket to the power of 5. And as we know, expanding bracket to the power of 5, it will give 6 terms. By using the binomial theorem that a plus b all to the power of n is equal n and 0, a to the power of n. You don't have to copy the binomial theorem in your mind. You just need to remember how you are going to write the terms. So if we compare between the binomial theorem here and the value of a and b, we'll figure out that a is equal to x and b is equal to -2 and n is equal to 5. So by writing the first term, 5 is the power. First term is taken 0, and then first term x here to the power of 5 minus 2y to the power of 0. Notice that this will give me 1, and 5 above 0 will give me 1. So the remainder will be the first term x to the power of 5. Then, as we said, every term in the binomial expansion is consists of 3 components. First, the binomial coefficient. Second is the first term, and third is the second term. Notice that 5 minus 1 gives me 4. So from where I figure out this 4 by subtracting 5 and 1, and -2y to the power of 1, the base of the binomial coefficient here is 1. Then the third term, 5 above 2, x to the power of 3, and -2y to the power of 2. 5 minus 2 is equal to 3, so 3 here came from 5 minus 2 in the binomial coefficient. and 2 as the base here is equal to 2. Fourth term is 5 and 3, x bar 2, difference between 5 and 3, and negative 2y to the power of 3. Now let's find. You can find the binomial coefficient by using your calculator, or if you are not allowed to use calculator, you are going to use it by the formula r n factorial divided by r factorial multiply n minus r factorial. So the coefficients here are 1 and 5 and 10 and 10 and 5 and 1. Then x bar 4 multiply negative 2y. Later, right now, we are going to multiply the 5 by negative 2. When I multiply 5 by negative 2, it will give me negative 10. So notice here, the second term is negative. And then 10 multiplied by 4 is equal to 40. And then negative 8 by 10 is negative 80. And 5 by 16 is equal to 80. And 1 by negative 32 is equal to negative 32. Notice that the power of x is going to decrease and the power of y is going to increase starting from the second term. Example of how we can expand bracket of binomial to the power of 5. 2x minus y to the power of 5, and as we know that power of 5 will give me 6 terms. 1, 2, 3, 4, 5, and 6. Each term of these is consists of 3 components. Every term consists of 3 components. Let's start with the first term. This time I'm going to solve it vertically. So the first term is the power with 0 before the number of the term. Then the first term, 2x, taking the difference between 5 and 0. And then the second term, taking the base of the binomial coefficient. Then the second term is 5 and 1 as a binomial coefficient, and 2x 5 minus 1 is equal to 4, and negative y to the power of 1, and the power of 1 is the base. Power of 1 is the base. Then the third term is going to be 5 and third term will be 5 and 2 as a binomial coefficient, and 2x to the power of the difference between 5 and 2, which is equal to 3, and negative y to the power of 2. Fourth term is 5 and 3, 2x to the power of 2, negative y to the power of 3. Fifth term, 5 and 4, or 5 above 4, 2x to the power of 1, and negative y to the power of 4. Finally, the sixth term, 5 and 5, 5 above 5, 2x to the power of 0, difference between 5 and 5, and negative y to the power of 5. So let's simplify it. We notice that 5 and 0 is 1, and negative y to the power of 0 is 1, so it's 2x to the power of 5, and notice that it's also 2 to the power of 5 and x to the power of 5, so it's 32x to the power of 5. Then 5 above 1, which is equal to 5, and 2 to the power of 4 is 16x to the power of 4 multiplied by negative y. So 16 multiplied by 5 is equal to 80x to the power of 4y, and I put the negative at the beginning. So the first term here is 32x to the power of 5, and the second term minus 80x to the power of 4y. Then the third term, 5 above 2 by using my calculator, is equal to 10. So it's 10 multiplied by 8, x power 3, and negative y to the power of 2 is y squared, as negative and the power of even is positive. So it's 80x x power 3 y power 2. So here is plus 80 x power 3 and y power 2. For the fourth term, 5 above 3 is equal to 10 by using my calculator, and 2 to the power of 2 is 4, x to the power of 2, and negative y power 3 is negative y power 3. So negative 4 by 10 is negative 40, x to the power of 2, y to the power of 3. So the fourth term is negative 40, x to the power 2, y power 3. Fifth term is 5 above 4, which is equal to 5 multiply 2x, and negative with the power even is positive y to the power of 4, so it's 10x y to the power of 4. So here is plus 10x y to the power of 4. Finally, 5 above 1 is 1, anything power 0 is 1, so it's negative y to the power of 5. So the last term here is negative y to the power of 5. Notice that if you have binomial expansion to the power of 5, it gives me the first term positive, but the second term negative, then positive, then negative, then positive, then negative. Now, for finding a particular term in a binomial expansion by using the binomial theorem. If r plus 1 is the first term of expansion of a plus b to the power of n, or I am looking for a particular term, I'm using the formula n above r, whereas n is the power outside the binomial, and r is 1 less than the number of the term, and a is the first term taking the difference between n and r, and b is the second term taking the base of r. For example, finding a single term of a binomial expansion. I am looking for the fifth term in this expansion. Again, the rule is n and r, n minus r and br. So 2x plus y to the power of 9. I'm not going to expand the whole 10 terms of this binomial expansion. I just need the fifth term. So the fifth term consists of 3 components. The first one is the power, and 1 less than the number of the term, so 9 and 4. And then the first term, 2x, taking the difference between 9 and 4, and the difference between 9 and 4 is 5. Then the second term is y, taking the base, and the base is 4. Now let's simplify it by using my calculator. 9 shift c of 4 is equal to 126, and 2 power 5 is 32, x to the power 5, y to the power 4. So 126 multiplied by 32 is 4032 x power 5, y to the power 4. And this is how to find a particular term in a binomial expansions. Another example for finding the single term or a particular term in a binomial expansion. Find the fourth term in this expansion. So we know that the fourth term consists of 3 components. First, here is the binomial coefficient, and the binomial coefficient consists of the power and 1 less than the number of the term, so 7 with 3. Then the first term, which is 3x, and 7 minus 3 is equal to 4. So let's write it 7 minus 3. And then 2y to the power of the base, and the base is 3. So it can be written as 7, 3, 3x to the power of 4 multiply 2y to the power of 3. Let's expand it. By using my calculator, I can figure out the value of the binomial coefficient. 7 shift c3, 35. So 35. And then 3 to the power of 4 is 81. X to the power of 4, and 2 power 3 is 8. Y to the power of 3. So now I need to multiply 35 and 81 and 8. It gives me 22,000 680, x to the power 4 and y to the power of 3. Write the first three terms in each binomial expansions expressing the result in simplified form. X plus 8 plus 2 to the power of 8. We know that the first term is always taking the power, so it's x to the power of 8. And then the second term consists of three components. The first one is the binomial coefficient 8 with 1 because it's the second term, and the first term x to the power of the difference between 8 and 1, which is equal to 7, then 2 to the power of the base here, which is equal to 1, plus 8 and 2, x to the power of 6, and 2 to the power of 2. So it's x to the power of 8 plus 8, c1 is equal to 8, x power 7 multiplied by 2 plus 8c2. By using my calculator, 8c2 is equal to 28, and x to the power of 6 and 2 to the power of 2 is 4. So it's x to the power 8 plus 2 multiplied by 8 is 16x to the power of 7 plus 28 multiplied by 4 is equal to 112 x to the power of 6.